Hello everyone, today we are looking at a real FE exam question from structures. Identify the correct pair of moment and deflection diagram that best represent the loading scenario illustrated from the continuous beam. This particular question has come in FE exam so many times, it's very easy, so pay attention. We have a beam here which is fastened into a rigid wall, and then there is rollers. Two of them are support rollers Q and R, and one is the end roller P, and then there is a point load acting in the center at C doing a load of P. We are given four options, each with bending moment diagram and deflection. The easiest one when such kind of choice is provided is always deflection, because the deflection exactly follows the actual sag that happens to the beam. For example, there is self weight present in this beam, and between this wall and the roller R, the actual beam is going to sag, right? Because the beam has its own self weight which will be acting through the center of the beam, right? So even though it is supported on both the sides, a sag is pretty much natural. So this sag is at its lowest in the center. Why? Because self weight of the beam is acting through the center, and for this reason the deflection is going to be a curve between the roller and the wall. And though you would expect there to be another curve happening between these two rollers, but in reality the curvature is going to arch all the way up from this side. The same happens from here. P and Q will be a curve here, whereas from Q and R there will be a curvature arching all the way up. So between Q and R the deflection is going to top itself, and between P and Q it's going to be a sag. So sag or a smile between P and Q, a frown or a concave up between Q and R, and another sag between R and S. So that is present in option A. Option B, option C is showing sharp rectangles, which is not how deflection happens. Option D on the other side is showing the exact opposite of what I just told you. As I was telling you, a sag always means negative deflection, which is very closely corresponding to options A and B. So the right answer is between these two. Now, which one is the right answer? Before I get into that, I need you to understand the positive bending moment and the negative bending moment. Positive bending. So what exactly is bending moment? Bending moment is the internal resistance to oppose the sag. So if sag is happening downward, there is an internal resistance which would be happening upwards, right? Which is the reason if there is a sag happening like this, the internal resistance is going to be positive because deflection is negative. There is always a kind of opposite relationship between them. Got it? So that's because the BM is an internal resistance. It's a resisting force. So it's always opposite to the direction of the self weight and point loads, always. So if you look at this particular option, there is a point load acting in the center at C, and option A is showing bending moment spiking in the same direction as that. That is not at all the right answer, because the point load will be resisted by bending moment, meaning bending moment will be opposite to the direction of point load, like I just told you. So in option B, that is exactly what happened. Exact point where this point load is acting, it spiked in the reverse direction. That is exactly what I was expecting to happen. So option B is more appropriate than option A. That's how I know this is the right answer. This is a very important question which also pops up in your PE, but let me tell you guys, they don't really make it very hard in the exam. They keep it very easy. So don't worry too much about it. And if you want some basic rules, I'm gonna tell you. So at the ends, the bending moment is always usually 0. So because there is no rotation that happens in the ends. In the supports, bending moment is pretty much carried over, but here there is a point load acting. So because of the point load, the natural bending moment was not carried, but it was rather opposed, which is the reason instead of this one going into a straight line like this between all the moments, so it was like reversed because of the additional point load acting. This additional point load created a new shear force which created a negative bending when the actual bending was actually positive. So that's why that happened. Here is a list of like some of the rules, or this is actually my own observation of this diagram. So positive bending moment is nothing but it happens when there is a sag or a smile. A smile or a sag means positive bending. A hog or a frown means negative bending. Very simple, right? Sag means positive, frown means negative. And whenever there is a positive moment, the beam is going to deflect downwards, right? Because positive bending moment means sag. Sag means the deflection is downward. It's very, very easy to understand. So when there is a pin or a roller at the end, bending moment is zero. When there is a fixed support, it is not zero. But in this, only for FE, please remember, I don't know why, but FE considers that a rigid wall, there is no bending moment over there. That's why in the option B, you see there is just zero in this end. But usually, if it's a fixed support, then it tends to have a bending moment. Now, the possible explanation is because there is no load acting in between this rigid wall and the roller. Maybe that's why that happened. So, yeah, don't try to complicate this question too much. It's a very simple, straightforward question, and they usually don't even change any of the options when they present this in the actual exam. So, all the best. Ciao.